Hello, students. Welcome to day one of mutations. Today, we're going to go over something for which you need to understand all the last stuff we did. So, real talk, if you don't understand what we did before, or if you didn't do what we understand, just go back and study. And of course, I think the best way is to reach out to me or Mr. Williams or the other ones, Miss Carr or Miss Check, and any of those teachers can help you. All right. So with that said, today by the end of class, you should be able to define and identify point mutations, substitution, and silent mutations. All right. So, again, what we're doing is kind of a continuation of stuff we learned. So, first question, what is a mutation? Well, a mutation is a change in DNA. So, here in the picture, you can see that like these colors have changed. Whoa, this was the original, something has changed here. And specifically, it's a change in one of the bases. So remember, we have bases C, G, A, T, and if you just follow through, here is G, 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 and here is G, A, and here is T, T, and here is the change T, G. Those are mutations. So now what causes mutations? Well, in general, things in the environment cause mutations. And some of those things are radiation, chemicals, and infectious agents. All of these things can cause mutations. Um, so now let's get into material associated with the learning objective. Remember, if mutation is changed, today we're going to talk about types of mutations. All right, so who cares, right? Well, mutations matter because if mutations change, then proteins change. And obviously, if our proteins change, then what our bodies are made of is different. And sometimes that can be helpful, and sometimes that can be harmful. All right, so now to cover the mutations. All right, something called point mutations. So a point mutation is a change in one base in the DNA sequence. So notice that here is T stands for thiamine in the original sequence of DNA, and then there's a point mutation, bam, thiamine for some reason mutated into cytosine in this example. That's a point mutation when one base changes. Next, something called substitutions is when one or more bases are replaced by the same number of bases. So example, here you see, T, G, and C in the original sequence, and then T, G, and C gets replaced with GAT. And that is a substitution when one or more bases are replaced by the same number of bases. So one could argue that point mutations happen because of substitutions. We could make that argument. All right, so now this is where it's going to kind of get a little tricky. I'm going to go away here. So there exists such a thing called silent mutations. And the silent mutation is when the DNA changes, but the resulting protein is the same. So let's first look at the original sequence. All right, so the original sequence is now what's in colored here and what's written here are the same. It's TAA, CCG, and GAC. Now remember, to get from DNA to protein, you have to discover which amino acid it codes for. So we first do DNA, and then we transcribe it into RNA, and then we translate it into an amino acid. And then in theory, this amino acid is a protein. Okay, so now look, there is a change here. CCG has mutated to CCA. CCG has mutated to CCA. Okay. But if we follow the codon wheel, and this is what's highlighted in green here, CCG G transcribes to GGC and then translates to glycine. CCA transcribes to GGU, but then also translates to glycine. So remember, we look for how the RNA transcribes to the amino acid. GGC becomes glycine, and GGU become glycine. Just recall, looking at the center column, we know there is a mutation. We see that they have transcribed differently. But we know that this codon and this codon translate to the same amino acid. So despite the fact that there is a mutation, the protein has not changed. All right, so next up for you guys, hello, stop presenting. Next up for you guys is some practice. So when you go to step 2, what you'll see is this practice, mutations practice. And it lists the original DNA and the mutated DNA and asks the question, what kind of mutation is this? How do you know? So in here, you're either looking for point mutation or substitution. Same deal, point mutation or substitution. Then it asks you to write an example of a point mutation, making sure that each box has 3 bases in it. So that's 3 letters, just like up here. But make sure that you are just doing a point mutation. And then finally, write an example of a substitution mutation. So again, the original DNA and mutated DNA. Again, make sure each box has 3 bases in it. Okay. And then down here is the tricky stuff. So is this whole thing, is this an example of a silent mutation, and how do you know? So remember, to study if this is an example of a silent mutation, look at how DNA transcribes to RNA and translates to the amino acid. So look for the mutation and look at how it transcribes, determine on how it translates. And here's a codon wheel for you to use. Similar problem with a little less information. So this one's just going to be a little more work. Again, is this an example of a silent mutation? How do you know? So the transcription is done for you on the first row. In the mutated DNA, I'm going to ask you to do the transcription on your own and the translation on your own and determine, is this mutation from this DNA into this DNA a silent mutation or not? All right, so with this practice, we'll be checking your work. Of course, if you just want help, if you want a teacher to do this with you, reach out to me or Mr. Williams or Miss Carr and Miss Chick would be happy to walk you through this, one kid at a time, one problem at a time. It's really, really our pleasure. So with that said, good luck, everybody. I hope you're also answering the Monday, Wednesday, and Friday questions. They should be, I can't wait to see what you guys say. Have a really, really good day.